Hello all and welcome to the Math 8 video for factoring expressions. In this video we're going to be talking about basically undoing or reversing what we've done when we've done the distributive property. Okay, so in this case what we're going to be doing is we're going to be taking something out, and when we use the distributive property we multiply. Okay, but in this case when we factor something we're going to end up dividing something out. Okay, so starting off here with a few things and notes, and then we're going to jump into some examples. But here we've got what the definition of factoring is. So separating an expression back into a product is called factoring. Okay, so once again, we see this word product, as we've seen before. That means multiplication. So when we separate it back into multiplication, that means we're going to be taking something that looks like this, which, as you've seen in previous sections, that's an expression that we call is in simplest form. Okay, well, what we're going to do is we're going to take that expression and we're going to essentially bring back the parentheses and basically undistribute, meaning we're going to take a factor from each term here and we're going to bring it outside. Okay, so in this case what we're going to do, and you'll see here in just a second, we're going to go over the steps to factoring something. But what we've got here is we can see 2x, that's 2 times x. Well, it has a factor here that you can clearly see of 2. Okay, the 8, if you know your times tables and you know what a factor of a number is, a factor of 8 is also 2. So since both 2x and 8 both have a factor of 2, so here we say common factor is 2, we can take out the 2. Okay, so one way you can think about doing this is you could say, okay, we have the number 2. What are the factors of 2? Well, if you remember from 3rd or 4th grade, maybe 5th grade, depending on when you first learned this, the factors of 2 are 1 and 2. And because of this, since it only has 2 factors, 1 in itself, we call 2 a prime number. Okay, but 2 is a prime, so its only factors are 1 and 2. But if we look at 8, it's got more factors. So 1 is a factor of 8. 2 is also a factor of 8. 4 is a factor of 8. And 8 itself is a factor of 8. So 8 actually has 4 different factors. Okay, so what we need to do in this case is we need to see, okay, do these numbers have any factors in common here other than 1? Okay, every number is going to have 1 as a factor. Okay, but here we see they have a common factor that is 2. So what that means is we come over to here and we take 2x and divide it by that common factor. So if we do 2x divided by 2, those 2's will cancel out, leaving us 1. So it would be 1x. Okay, we have to do the same thing with the 8. If we do 8 divided by 2, that gives us 4. So the final step here is once we take out, so what did we just divide by? We divided by 2. So the factor that we divide by, we take outside the parentheses, and then whatever's left on the inside is going to be what we got when we divided here. So it's going to be 1x, or x in this case. So you can leave off the 1. So let me do that. But 1x, and since it's plus here, so 2x plus 8, it's going to be a plus on the inside of the parentheses. And then what was it when we divided 8 by 4? We got 4, sorry, 4. Okay, so when we factor something out, it's going to look like this, okay, where we've got a common factor on the outside of the parentheses and 2 terms on the inside where, once again, that the terms are what we get after we divide through by the common factor. Okay, so as you'll see in just a second, when we look at the steps, you can actually check yourself if you factored this correctly by just distributing this back out. Okay, so based on what we've done before, we can take the 2 times x gives us the 2x plus 2 times 8 or 2 times 4 gives us the 8. So that means that is actually the factored form of our expression. So before we jump into a few more examples, okay, so we're going to work a few examples. Every single question works the same way, but we do have a few official steps that we need to follow here, okay? So the first step, just like we did in the last one, we need to find what is called the greatest common factor, or you'll see it shorthand sometimes written as GCF, okay, of each term. That's what we did when we broke down the terms and we see, well, what's the greatest factor that they have in common? What's the greatest common factor, okay? And that in this case was 2. So that was the first step that we did right there. We found the greatest common factor. The next step is to divide each term by the greatest common factor, okay, and then leave the remaining factors in parentheses. So what that means is what we just did right here. We took 2x and divided it by 2. So that means x, or 1x, was our remaining factor. Same thing here. We took 8 and divided it by 2, the greatest common factor. So in this case, 8 divided by 2 gave us 4. So 4 is the remaining factor that stays inside the parentheses, or put them in parentheses. Okay, and then the last step here is what we did at the very end, where we checked by distributing. So we could take this 2, multiply it out. So 2 times x gave us the 2x. 2 times 4 gave us the 8, and since it's plus on the inside of the parentheses here, that means it's plus right here, and vice versa. So just pay attention to the signs here, if it's addition or subtraction. I do have to say, don't really have to worry about negatives so much in this section, because we're just talking about factoring expressions in a very basic way. Now, you can factor out negative numbers, but that's something that you'll see more in a strict algebra class setting. Okay, so for Math 8, we're just going to take this very slow, going to look at factoring expressions very basically, okay, and not really deal with negative numbers at this point. But let's go ahead and jump into some examples, okay, so we can see how these types of questions are going to work. And once again, every single question is going to work the exact same way, okay? So I do need to add something there. I realized I forgot. So let's go on to example 1. Example 1, 7x plus 7. So technically what you would want to do is you want to find what is the greatest common factor of 7x and 7, okay? So in this case, 7x, well, each term doesn't have a variable, so x can't be a factor here. But we can look at the 7s, okay? So what are the factors of 7? Well, if you know anything about the number 7, you know that the factors of 7 are 1 and 7. And just like 2 that we did in the first slide there, 7 is considered prime, okay? Now, technically, you don't have to write this out again because we have the number 7 here again. So obviously, the biggest factor of this 7 is going to equal the biggest factor of this 7. But just so you can see and kind of get a sense of how we're going to do these, look at the factors. The factors of 7 are 1 and 7. The factors of this 7 are 1 and 7. So the greatest common factor between those two is 7. So what that then tells us is we're going to take out a 7, and then what's going to be left over? Well, if we do 7x divided by 7, we just get 1x, okay? 7 divided by 7 is just going to be 1. And since it's plus right here, it's going to be plus in the middle of the parentheses, and that's our final answer, okay? You take out the 7, you're left with x plus 1. So you've basically what we've done here is we factored out a 7, meaning 7 goes on the outside of the parentheses, and what's left, once again, when we factor, it's basically we're dividing out a 7, meaning this term loses a factor of 7, and this term loses a factor of 7. So once again, what's left over is what we get after we divide. But that's actually it. Now, this is a really easy example because 7, okay, it's a prime number. There's only two factors, and obviously the same numbers have the same factors. So this 7 has the same factors as this 7. So that's how that worked out. Now, when we go to number 2, ratchet up the difficulty just a little bit here. We look at 4k plus 20. Okay, so each term we want to look and see what is the greatest common factor here. Well, once again, we have k here in this term. There's no k in the 20, so k can't be a factor, so we don't need to worry about the variable here in terms of it being a factor. So what we've got to check is, let's check the number 4, and let's check the number 20. Okay, so what are the factors of 4? Well, the factors of 4 are 1, 2, and 4. Okay. Once again, I'm kind of glancing over the idea of factors here because, once again, this should be something that you should know. But just to kind of remind people, the factors of a number are the things you can multiply together, whole numbers in a way, whole numbers that you can multiply together to get the number 4. Okay, so 4 can be 1 times 4. 4 could also be 2 times 2, or 4, which it's the exact same. It could also be 4 times 1. So once again, all these are factors of the number 4. 20, on the other hand, it has a lot more factors. Okay. Once again, every number has a factor of 1. Since this number is even, it also has a factor of 2. 3 is not a factor of 20 because there's nothing you can multiply times 3 that's a whole number to give you 20. But 4 is a factor of 20. 5 is a factor of 20. And 10 is a factor of 20, and then 20 itself is a factor of 20. Okay. Now, once again, there are some tricks you can use to figure out all the factors. Okay. The biggest one, which you run into trouble with bigger numbers, is literally just take every number that's less than 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to 19. And divide 20 by those numbers. And if you get a whole number out, then whatever number you had there that you divided 20 by is a factor. So if we divide 20 by 1, we get 20. We divide 20 by 2, we get 10. We divide 20 by 4, we get 5. We divide 20 by 5, we get 4. We divide 20 by 10, we get 2. And we divide 20 by 20, we get 1. So all that means is all of these are factors of 20. But once we figure out the factors, all we got to do is figure out, well, which one's the biggest? And in this case, that is the number 4. So 4 is the common factor. So we take out a 4, and then we kind of do the same thing. What happens when we take away a factor of 4 from 4k? Well, it's just going to leave us with 1k. Plus, if we take away a factor of 4 from 20, that's going to leave us with 5. So once again, you basically just divide here. 4 divided by 4 gives us 1k plus 20 divided by 4, 5. Okay, so I'm going to try to pick up the speed a little bit here because, once again, every single question works exactly how I just did those previous two examples. So number 3, okay, same kind of thing here. Let's look at the factors of 5m. Well, once again, this term has an m, this term has nothing as far as a variable, so m can't be a factor, so we just need to look at the numbers. The factors of 5 and the factors of 15. So in this case, factors of 5 are 1 and 5 because 5 is a prime number. Okay. And then the factors of 15, once again, whatever way you figure out the factors, whatever way is easiest for you, but the factors of 5 you should get are 1, 3, 5, and 15 itself. Okay. But in this case, once again, we technically didn't need the 15 here because the biggest factor of 5 is 5, and we saw 5 is also a factor of 15. So our greatest common factor in this case is 5. Once again, this is the greatest common factor. 4 is the greatest common factor. 5 in this case is going to be the greatest common factor. So once again, that tells us what we divide out or we take out of the parentheses. So we're going to have 5 on the outside of the parentheses. And once again, what's left over? If we divide 5m by 5, we're going to be left with 1m. Since it's minus here, we're going to have minus inside the parentheses. And then 15 divided by 5 leaves us with 3. So once again, it's basically you're dividing out a 5 there from both terms and putting it on the outside of parentheses. And I haven't been doing this, but with every single one of these, you can check and see if you did this right by distributing the 7 back through, in this case 7, or the number out back through. So 7 times x is a 7x, plus 7 times 1 is 7. 4 times k, 4k, plus 4 times 5 is 20. 5 times m is the 5m, minus 5 times 3 is 15. Okay? But then we get to number 4, and this one's a little bit tricky. One, because the numbers we're getting into are getting a little bit bigger. But then we also see there's actually 2 variables here. Okay? So in this case, we have 6r minus 48s. Well, what we see here is this term has an r, this term has an s. So this is in simplified form because these are not like terms, meaning we can't just do 6 minus 48 and get a simpler term here, okay? So what we've got to look at is, well, what are the factors of 6r? Well, there is a factor of r here, but there's no factor of r over here with the 48s. And vice versa, there's a factor of s in the 48s, but there's not a factor of s in the 6r. So what we can do is, if the variables here are not the same, if we have more than one variable, if they're not the same, then you don't have to worry about taking out a variable, meaning you can just ignore the variables in this case and look at the numbers, okay, when you're looking at factors. So what I mean by that is, now we just look at what the factors of 6 are, and we look at what the factors of 48 are. Now the factors of 6 should be pretty easy. The factors of 6 are 1, 2, 3, and 6. But 48, there's actually a lot of factors of 48, okay? Factors of 48, 1, 2, 3 is actually a factor of 48. 4 is actually a factor of 48. 6 is a factor of 48. 8 is a factor of 48. So that 12, after that 12, then 16, then 24, then 48 itself. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different factors for the number 48. But technically, we didn't have to list out every single factor here. We could have stopped after the 6, because as you notice, the biggest factor of 6 is 6. Well, it doesn't matter what the biggest factor of 48 is. We want the greatest common factor, meaning we have to have one that's in common with 6. So in that case, it is, in fact, 6. So in this case, once again, we're going to take 6, take it out of each term here. So if we divide 6r by 6, we get 1r. So that's just r minus, in this case, 48 divided by 6. That's a little bit of a tricky one, but once again, if you know your times tables, helps you out with factoring, because if 48 divided by 6 gives us 8. But then here we can't forget there's also still an s there, so 8s. So the final factored form here, the final answer is 6 times, in parentheses, r minus 8s. Okay. And that's as tricky as the questions get in terms of the hardest, because once again, we did have a pretty big number here in terms of how many factors there were. Okay, so if you're actually listing out all the factors, it took us a little bit of time there. But then also having to deal with 2 different variables here. But once again, if you do have 2 different variables, like I said, because they are different, you can kind of ignore them. Now, when I say ignore them, that doesn't mean you got to leave them in the final expression. So the r still has to be in the first term place, and the s still has to be over here with the second term. But when you divide out, all you're going to be dividing out is a 6. All you got to look at is the numbers. So 6 divided by 6 gives us 1r. minus 48 divided by 6 is 8s. Okay. But let's go on and pick things up here, get through some more examples. So example 5, in this case, 12 and 24. So 12w plus 24. We need to see what the factors of 12w are and the factors of 24. And once again, this is a term with only one variable, meaning, or an expression with only one variable, meaning we have 12w here, but the 24 doesn't have a w, meaning we don't have to worry about the w becoming a factor. So when we look at the numbers, that's just all we have to look at. We need to look at 12 and 24. And once you get through with this, if you get good at doing factors in your head, you actually don't have to write out and do as I'm doing here. You don't have to write out every single factor and figure out which is the greatest one. Okay. Some people can just look at this and say, okay, I'll go ahead and tell you the greatest factor here is 12. Because we know 12 can divide 12, but then 12 can also divide 24, okay? And that would be the greatest common factor. Where people get mixed up is they say, oh, this is an even number, this is an even number, so the greatest common factor is just 2. But if we do that, we do 12 divided by 2, we get 6w right here, plus 24 divided by 2 is 12. And a lot of people would say, okay, that's the answer, that's it. But we have a problem with this. If we look real closely, we can actually do that again if we wanted to, because we could take out another factor of 2 or a factor of 3 if you see that, okay, or a factor of 6, okay. So this isn't correct in that we have to have out here, we have to have the greatest common factor, meaning there can't be any common factors left over here. So in this case, 6 and 12, we can't have that because once again, they both at least share one other factor. So once again, make sure you get the greatest common factor, and if you need to, this is the way you can do it, is just write out all the terms, or write out all the factors. So factors of 12 are 1, 2, 3, 4, 6, and 12. Okay, so good bit of factors there. And then the factors of 24 are 1, 2, 3, 4, 6, okay, 8, 12, and 24. So a few more factors there, actually 2 more factors than 12, okay? But once again, we technically didn't have to go past 12 here, so we didn't need to know 24 as a factor, even though that's one of the easier ones. But we see both of them have in common a factor of 12. So the greatest common factor is 12, so that means we take a 12 out, meaning 12w divided by 12 leaves us the 1w, plus 24 divided by 12 leaves us with 2. So that's our final factored answer, which is 12 times, in parentheses, w plus 2. Okay. So then we get to number 6, and I'm going to put a little star by number 6 because this is a special case here. Because if we look, some of us can see right off the bat, there's a little issue here. Because we have 2 here and we have 9. 2 being prime, 9 being 3 times 3. Okay. So, but as you can see, they're both, one of them's even, one of them's odd. That's not the only thing that matters here. But when we look at the factors, something happens. So the factors of 2 we've already talked about are 1 and 2. That means 2 is prime. Okay. And the factors of 9 are 1, 3, and 9. So if you notice here, what is the greatest common factor? Well, the greatest common factor in this case is 1. Okay. So if 1 is the greatest common factor, if you take out and divide through by a 1, it actually doesn't change anything. 2p divided by 1 is still 2p. 9 divided by 1 is 9. Okay. So if your greatest common factor is 1, that tells us our expression here is what we call also prime. Okay. Meaning that the only factor we could possibly take out is a 1. But instead of taking out a 1 and writing it as like 1 times 2p minus 9, okay, we just simply write prime because in this case, it doesn't make sense to factor out a 1 because if we divide through by a 1, it stays the exact same. Okay, so when you go through this process or you can't find any factors other than 1 that match with each one of your terms here, then the answer is prime, meaning that you can't actually factor it. So if you look at the instructions on the actual sheet that you've been given, it says if the expression cannot be factored, write prime. Okay, and once again, that tells us that the only factor that these terms have in common is 1. Okay, so you'll see that again here in just a few minutes, but I did want to put a little star there because this is something that could happen. You could have two numbers here that don't share any factors other than 1. Every term is going to share a factor of 1, okay? But that might be all they share, and in that case, it's prime. Number 7, going a little quicker here, we can see the factors of 4 are 1, 2, and 4. Factors of 10 are 1, 2, 5, and 10. Well, the only ones that they have in common are 1 and 2, so 2 being the biggest, so our greatest common factor is 2. So we can factor out of 2. In this case, 4n divided by 2 leaves us with 2n minus 10 divided by 2 is 5. And once again, that's because the factors of 4 are 1, 2, and 4. Factors of 10 are 1, 2, 5, and 10. And that tells us, once again, greatest common factor is 2. And then once again, it's just dividing in this case. You divide 4n by 2, so 4 divided by 2 is 2. So you have 2n minus 10 divided by 2 gives us the 5. Number 8, a little trickier here, okay? But we can see both of these numbers are divisible by 5, and that's actually the greatest common factor. But if you need to, once again, come down to the side, to the bottom on another sheet of paper, and just write out all the factors. The factors of 10 are 1, 2, 5, and 10, just like we saw before. The factors of 45 are 1. 3 is actually a factor of 45. 5. Okay, 6, 7, 8 are not, but 9 is. 10 is not, but 15 is. And then lastly, we have 45. But once again, we technically didn't have to go past 10, so we could have stopped at the 9 and knowing 10 wasn't. And that tells us that our greatest common factor here is 5. So we take out a 5, meaning 10v divided by 5 is 2v, plus 45 divided by 5 is 9. And once again, with every single one of these questions, you can double check yourself by going back through and saying, okay, 2 times 2n gives me the 4n, minus 2 times 5 gives me 10. 5 times 2v gives me the 10v, plus 5 times 9 gives me the 45. Okay. Now, last 4 examples for this first page here. We've got 6k plus 21. Once again, factoring out the greatest common factor. Okay. Once again, you can go through and write out all the factors, but I'm going to pick it up just a little bit here just to save us some little time, make the video a little shorter. But in this case, I'll tell you the greatest common factor is 3. So if you take out a 3, then 6k divided by 3 is actually 2k, plus, since it's plus here, 21 divided by 3 gives us 7. And once again, if you want to double check it there, 3 times 2k, 3 times 2 is 6k, plus 3 times 7 is 21. So that's actually the factored form. Number 10, we run into an issue where we have the 2 variables again, but once again, they're 2 different variables, A and B. So we don't have to worry about the variables in this case, except just to make sure that we write them down again when we factor it. But in terms of looking at factors, we don't care about the A and the B here. So we know both of these are even, so they share a 2 at least. Let's think about it a little bit more. 3 is not a factor, but 4 is a common factor there. Okay. And I'll go ahead and tell you that's where you can stop. So 4 is actually the greatest common factor. Once again, if you need to, take the 16 down here, list out all the terms or factors. 12, list out all the factors, and the biggest one they have in common would be 4. But if we take 16a divided by 4, we get 4a minus, okay, since it's minus here, 12b divided by 4 is going to be 3b. Okay, and then once again, just to double check and make sure that's the right answer, 4 times 4 is 16. Then we still have the a, so 16a minus, okay, which that looks a little bit more like a dot. I don't want to confuse anybody thinking that's multiplication there. Okay, but in this case, it's minus since it's there, and then 4 times 3 is 12, and then we add the b, so 4 times 3b is 12b. And that's it. That's all we're doing when we're factoring something. Number 11, well, we look here. In this case, we have 18 and we have 15, or 8 and 15. If you're super clever, you can see that they actually do not share any factors other than 1. So we could actually just go ahead and write the word prime. But once again, if you needed to, go down here and factor each number. Factors of 8, 1, 2, 4, 8. Factors of 15, 1, 3, 5, and 15. Once again, none of the factors they have match except for the 1, which means, once again, this is prime. Okay, meaning you can't factor out anything other than a 1. And once again, we don't factor out 1s because it doesn't change anything. And then the last one here, some bigger numbers we're dealing with here, so a lot more factors. So if you do write out all these factors, there's going to be a lot of them. But once again, we look at them, we can see they're both even, so you could take out a 2. Okay, well, let's do that. Is 2 the greatest common factor? We'll take out a 2. That would leave us with 12y minus 20. Well, we know 2 is not the greatest common factor because look what we have in here. We can definitely see that they at least share another factor of 2. Okay. They actually, if you want to be thorough with it, you could both see that both of these actually have a factor of 4. But we can actually go from the very start and get it on the first try because we can notice, okay, 24 is divisible by 8, and 40 is also divisible by 8. So actually, 8 is our least or greatest common factor, meaning we take 8 out, so 24 divided by 8 gives us 3. We have the y minus 40 divided by 8 is 5. And then now, hopefully, you can clearly see, well, 3 and 5, the only factor that they share is 1, so that's actually as factored as we can get it. Okay. And once again, you can go down here and write out all the factors. Okay. So in that case, saving some time there. Once again, once you get better with this and you can think about what factors of numbers are, then it can be as easy as, okay, both of these have an 8, take it out. Or you can see both of these have a 4, take it out, but then realize that you could take out another 2, factor of 2. Or you could take out a factor of 2 and say, oh, well, I can still take out a factor of 4. So once again, practice through with these. Make sure that you understand how to factor because what we're going to go into next relies on us being able to do this. Okay. So we do have a little word problem question here, though. So if you go to the next page, the top question, it's kind of just checking to make sure that you know how to correctly factor. It says a question on a quiz asked students to factor the expression 32m minus 24. Ryan and Jane's answers are given below. Explain who is correct and why. Well, if you check both of them, okay, by distributing, you would see Ryan has 4 times 8m, which is 32m, minus 4 times 6, which is 24. So his actually checks out in terms of the distributing. So he factored out a 4, but look what's on the inside left over. We have an 8m and a 6. So in this case, we can see both of those are even. So that's actually not completely factored because, once again, you could take out another 2 here. Okay. Whereas if we go over to Jane and we distribute out, we get 8 times 4m, which gives us the 32m, minus 8 times 3, which is 24. So it also gives us this expression, but it's actually completely factored, because if you look at the inside here, 4m minus 3, well, 4 and 3, they don't share a factor other than 1, okay? So the answer here is Jane is correct, okay? And then it says why, okay? In this case, once again, it's when you get a question like this, it's kind of just up to you. Write out what you think, but in this case, one possible way you could explain why is Jane factored out the greatest common factor, whereas Ryan did not. So Jane, because she factored out the greatest common factor, so I'm using that acronym there, Ryan did not. Once again, he factored out a 4, but it wasn't the greatest common factor, okay? Once again, Jane is correct because she factored out the greatest common factor, okay? Technically, Ryan factored something out, but it's not completely factored, because once again, one technicality of factoring something is you got to have the greatest common factor, meaning you need the biggest possible number on the outside of the parentheses, okay? But now let's get into some of what we are really doing in this section, which is kind of combining what we've done in the last little bit in terms of simplifying expressions, okay? So what we're going to do here is we're going to have something that's written out like this. We're going to be asked to simplify it, and then after we simplify it, we're going to be asked to factor it, okay? So in this case, we're simplifying, then factoring. So the directions actually say simplify and factor each expression. So I'm going to blaze through the simplification because, once again, this should be something done a little bit here, so you should know how to do the simplification part, okay? What we need to really practice with is the factoring, okay? So what I mean by that is, let's simplify this. So as always, I'm going to write this as a sum first. Put a 1 in front of the x there just so we know what the coefficient is there. 4x plus negative 1x is 3x, plus negative 2 and 23 gives us 21. So that's the simplification. We just did this. This is simplified. But once again, we asked to simplify and factor, okay? So in this case, we're going to do exactly what we've just been doing with the last few questions is once we simplify it, like we've done before, now we're going to take it and find the greatest common factor between the terms. So in this case, I'll go ahead and tell you the greatest common factor here is, well, let's actually write it out this time so we can see. 3, the factors are 1 and 3. 21, the factors are 1, 3, 7, and 21. So the greatest common factor in this case is, of course, the 3. So what we're going to do is we're going to take it out and divide both terms by 3. So 3x divided by 3 is just 1x. So once again, just x. Now, if you do write it as 1x, that's perfectly fine. But you do need to recognize that 1x is also just considered x, okay? But then plus, since it's plus out here, 21 divided by 3 gives us 7, okay? And this is what we have when we factor. So this is factored, okay? So technically our final answer is going to be this because we simplified it, then we factored, okay? And technically, I guess both of these are the answers. So because they want us to simplify and factor. So we need the simplified version, and then we need the factored version, okay? And that's what all the rest of these questions are like. So the next, in this case, the next 7 questions are all the same, meaning we're going to simplify the expression and then factor it. So when we look at this one, once again, got all these terms. We see subtraction there, which once again, some of you might be clever enough to deal with the subtraction right away. I am going to go ahead and put the 1 in front of the m, like I should have put the 1 in front of the x up here, because once again, we need to know that the coefficient in front of that m is technically, in this case, -1, because when we write it as a sum, we'll see that it would actually turn out to be a -1m. So once again, what can we combine here? Well, we combine 11m and -1m. So 11 plus -1 gives us 10m. Plus, in this case, we're going to have -13 plus 5. That's going to be a -8. So our technical simplified version is going to be 10m minus 8. So once again, this is simplified. Okay, now we come over and we factor. Well, in this case, once again, you could sit there and write out all the factors and find that the greatest common factor is actually a 2. Okay, once again, this is an even number, this is an even number. You can take out a 2, but that's actually it, because after you take out a 2 here, you'd have a 5. Take out a 2 here, you'd have a 4. 5 and 4 do not have a common factor other than 1. So in this case, the greatest common factor is 2. So that's going to leave us with 5m minus 4. And that's actually our factored form. So after you get done with the simplification, once again, this is just a test of doing the same things that we've been doing with the last few examples, meaning once you get a simplified version of an expression, you're just trying to find the greatest common factor and divide it out. Okay. Number 16, same kind of thing here. We got this expression where we can simplify it a little bit. We got some like terms we can combine, but once again, I'm going to do the thing first where I write it as a sum. And in this case, we see, well, what can I combine with the 23p? Well, -3p, which gives me 20p, plus, in this case, -27 plus 2 is -25. So once again, that tells us our simplified version is 20p minus 25. Okay. Once again, we get our simplified version here. So that's technically one part of our answer. So now we need to go over here and we need to factor it. Well, what's the greatest common factor of 20 and 25? And that would actually be 5. So 5 is our greatest common factor. So when we divide through by that, we get 20p divided by 5 is 4p, minus 25 divided by 5 is 5. So it's 5 times, in parentheses, 4p minus 5. And once again, so I didn't do it on the last two, but you could go through and double check yourself, meaning in this case, you can't really check yourself on the simplification, but you can check your factored form, meaning to multiply it through. 3 times x gives me the 3x. 3 times 7 gives me the 21. 2 times 5m gives me the 10m. Minus, 2 times 4 gives me the 8. Okay. So just be careful on that. You can check, make sure that your factored form is correct. Okay. You just got to trust yourself and know that you're doing the simplification right. Okay. Once again, this is the simplified version. This is the factored version. Okay. So number 17, same kind of thing here. In this case, we actually have two different variables, so we do have to be careful here. We've seen questions like this before, but at the same time, I am going to write it as a sum so I can see what I can combine together here term-wise. So I can combine something with 7x, so I can combine 7x and 11x, which gives me 18x, plus And then now we can combine the y terms that we have. So negative 2 plus negative 8 gives me negative 10y. So technically the simplified version here is going to be 18x minus 10y. Okay, so once again, that is the simplified version. So what is the factored version going to be? Well, once again, we need to see, well, what is our greatest common factor? So you could sit there and list out all the factors of 18. You could list out all the factors of 10. But I'll go ahead and tell you the greatest common factor of those two is 2. Okay. So if we do 18x divided by 2, that gives us 9x minus, since it's minus here, 10y divided by 2 is 5y. And once again, that is our factored form. And once again, we need both of these technically for the answer to be right, because the question is asking for us to simplify and factor. So we're technically doing two different things here. We're checking two different things. Can you simplify the expression, and can you factor it? Okay. Now, starting with number 18 here, we run into some more familiar stuff, because here we actually have to use distributive property to simplify. Okay. So once again, knowing how to use the distributive property, I'm going to try to go a little quick through this, because hopefully everybody at this point can simplify an expression like this. But just like always, first step, I'm going to rewrite this as a sum. This one's a doozy to write as a sum because it's a lot of subtraction there, okay? But all I'm doing is I'm taking every bit of subtraction and writing it as addition. So that way I can clearly see what my terms are. But now I can see I'm distributing a 5. So 5 times 3a gives me 15a, plus 5 times negative 2 gives me negative 10. And then we still have the plus negative 13a plus negative 2. And now we can see, well, what terms can we add together here? What are the like terms? Well, 15a, I can add 13a, which gives me 2a, plus negative 10 and negative 2 give me negative 12. So once again, that'll simplify down to 2a minus 12. So that is our simplified version. So that's the first part. We simplified. Now we take and we factor it. And hopefully it's obvious to you at this point. The greatest common factor here will be 2. So once again, we take out a 2. So basically we undo distributive property and we take out a 2. So 2a divided by 2 is going to be 1a, minus 12 divided by 2 is going to be 6. So it's going to be 2 times a minus 6. And that is our factored version. Okay. So hopefully at this point everybody can see how all these types of questions work. So let's do the last 3 examples, and then that's pretty much it for the section. Okay. Now number 19, we got to remember, in this case, we see the parentheses here. So that tells us we need to distribute something, but in this case there's no number in front of it, so we can put a 1 in front of that set of parentheses. So now we can see when we write this as a sum, okay, I'm actually distributing a negative 1. So we still have the 1 plus 24k plus negative 1 times 4k is negative 4k, plus negative 1 times negative 17 is actually positive 17. So what we're going to end up with here is 24 plus negative 4 gives me 20k, plus 1 plus 17 gives me 18. And then once again, we would go through the process of what we did just a few minutes ago, where we take this simplified expression, which once again, this is our simplified expression, and we factor it. Okay, so we're going to factor it, meaning in this case, we're going to take out a 2. That's the greatest common factor here. And we're going to be left with 10k plus 9. So once again, all we're doing is dividing these through by 2. So 20 divided by 2 gives me the 10. There's still the k, plus 18 divided by 2 gives me the 9. Okay. Like I said, every single one of these questions works the same, but really relying on you being able to know how to simplify an expression. Okay. So, because that's a big deal in algebra, simplifying expressions, and to a lesser extent factoring. We're still talking about factoring, but because you definitely see it a lot in algebra. Okay. But being able to simplify, that is the main deal here, because if you can't simplify, well, then you can't factor. Okay. Because if you don't get the right answer down here, then your factored form is not going to be right as well. Okay. So once again, every single one of these, we're finding the simplified version and we're factoring it. We're finding the simplified version and we're factoring it. Okay. We're finding the simplified version and we're factoring it. Finding the simplified version, factoring it. Okay. So those two, same deal. So last two examples here. Okay. For the actual notes, same kind of thing here. In this case, we have an expression with two different types of variables. So first things first, I'm going to write this as a sum. And then I'm going to distribute. In this case, the distributing here has to be with a -3. So we're going to have 9m plus -6n plus, in this case, -3 times m is -3m, plus -3 times 6 is going to be -18n. Okay. So then from here, we got all our terms laid out here. 9m plus -6m plus -3m plus -18n. Can be tricky with all these negatives around here, but now we simply just combine like terms. So 9m, what can we combine with the 9m? -3m. So that gives me 6m plus -6n plus -18n actually gives me -24n. And then once again, we have this plus and minus, so we can rewrite that simplified as 6m minus 24n. Okay. And then that is actually our simplified version, because we don't have like terms. We can't simplify that any further. But now we can factor, though. In this case, our greatest common factor is going to be a 6. So 6m divided by 6 gives me 1m, minus 24n divided by 6 gives me 4n. And there is our factored version. Okay. Once again, same process every time. It's just you got to be really proficient with simplifying expressions before you can factor. Okay. Same thing here, a bunch of different. So last example here, and it's the hardest example. Same thing, bunch of different terms here, different variables, but we see the parentheses, so there's no number in front of the parentheses, so we could put a 1. That should tell us that we're distributing a -1, but if you can't really see that and it's hard to see, write everything as a sum, and then you can see the negative has to go with the 1, so you're actually distributing a -1 here. So once again, -1 times 6r, well, we're still going to have the 16r plus 2s plus -6r, because once again, -1 times 6r is -6r, plus -1 times 8s is -8s plus 4r. And then once again, we combine all the terms that we can. We actually have 3 terms we can combine with r's. So 16r, -6r, 4r. So 16 plus -6 plus 4. I'm going to shortcut that. Once again, you can double check this in a calculator. It's going to be 14r, okay? And then we're technically going to have plus, what are the s's here? Well, 2s and -8s. So 2 plus -8 is -6, and then we have s. So in this case, we do need to take it one more step and simplify one extra way. So 14r minus 6s. So that is our simplified version. And then now let's factor. Well, the greatest common factor here, once again, as it was with a few of these, is it's going to be a 2. So if we factor out a 2, or do we divide through by a 2, 14r becomes 7r minus 6s becomes 3s. And that's our factored form. Okay. So once again, being able to simplify expressions, then factor, relies heavily on you at first being able to simplify fractions. So if you need to practice with that a little bit and you're not able to go through and get the same things that I do here as you work these out, definitely go back and practice a little bit with simplifying expressions, okay? Because that is the backbone of a lot of what you're going to do in algebra. So being able to do that, then factor, is very good to know how to do for algebra, okay? Now, the last thing here, okay, and we're going to run through this pretty quick just because this is a little review sheet. So what I suggest you do is, before you watch the rest of this video, is do this sheet on your own, okay? Try to simplify. So it says simplify versus factor. Simplify all the expressions over here. Make sure you can get the right answers, because I'm going to go over these here in just a second. And then practice with factoring. So in this case, examples 11 through 16, you're factoring out. So doing the same thing we did on the first examples in this section. And then the last two here are basically the ones like we just did just a second ago, which is simplify and factor, or simplify then factor each expression. So like I said, I would pause the video here, practice with this, make sure, go through, work all these out, and then once again, we'll check our answers here right now. So once again, pause if you want to do this, and then come back to the video, and we're going to go over these right now, okay? Now with this, I am going to have to zoom in a little bit to give myself some ample space to write, okay? And then we'll move it around if we need to, okay? But in this case, we have simplify each expression. Once again, something you should have seen over and over and over again here. And once again, some of us could be good with just looking at this and saying this is going to be 8x plus 15. Okay. Once again, because you see 10x minus 2x is 8x. Negative 4 plus 19 is 15, positive 15. But once again, I like writing this as a sum first. And then that allows me to combine the terms. So 10x plus negative 2x, that's where we get the 8x. Plus negative 4 plus 19 gives me 15. So the answer to number 1, in this case we're just simplifying, is 8x plus 15. Number 2, very similar here. We're going to just simplify this expression, okay? And once again, some of us might be able to say, okay, well, we got 3k minus 8k, so 3k plus negative 8k. That's going to be negative 5k minus, in this case, since because we're going to have negative 6 plus 2, negative 4. So that's going to be negative 5x minus 4. But once again, if you have trouble seeing it right from the start like that, write everything out as a sum. And then we end up with 3k plus negative 8k. That's where we get the negative 5k. Plus negative 6 plus 2 is the negative 4. And then once again, technically, to have this simplified all the way, we need to write that as negative 5k minus 4. Okay. Number 3, same kind of thing here, except for we have 2 different variables, so be careful here, a's and b's. So we need to, I'm just going to do the a's first because they come first in the alphabet. But in this case, once again, I'm going to write as a sum. And I'm going to make sure to put a 1 in front of that b so I know that there's a coefficient of 1 there. But now let's add up all the a terms. 2a negative 18a, 4a. So 2 plus 4, see how I'm doing this, 2 plus 4 is 6, plus negative 18, that's actually going to be negative 12a, plus 7b plus 1b is 8b. Okay. Now, technically, you could have had it flipped around and had 8b minus 12a, okay? But usually, when you're writing something out like that, you like to, and it's just visually pleasing too, you like to write your, like to have your variables in order, okay? But like I said, however you want to do it there, but you could see clearly what the terms are, so that way you know what you can add together and what you can't. Number 4, same kind of thing here. Some of us might be able to look and see what's going to be negative 16 plus 9 minus 5. So negative 16 plus 9, that's going to be negative 7 minus 5. So it'd be negative 12m. And then minus, once again, technically, we can put a 1 in front of that n. Okay, minus 3n. But like I said, if you can't see it from there, just like always, we can write it as a sum. Just takes a little bit of work, a little bit of time, okay? But after we do that, we can clearly see what terms we can add together here. So what can we go with 16m? Well, negative 16, 9, and negative 5. So negative 16 plus 9 plus negative 5. Once again, that should be negative 12. And then there's an m that goes with it. And then we have plus, well, what are the n's going to be? Well, it's going to be negative 2n, negative 1, so negative 3n. And then the last step here would be to write it without this negative here, so negative 12m minus 3n. Okay. So with that being said, let's zoom out. Oh, no, we didn't need to do that. And then zoom back in so we can have some room to write these out. Now we're into some where you have to use distributive property. So to simplify number 5 out, it's just distributive property. So we're going to distribute the 9. So it's going to be 9y plus 9 times 5 is 45. And that's simplified. That's all there is to it. Okay. Number 6, same kind of thing. We're going to distribute a 2. So 2 times 8 gives us 16. Minus 2 times h is 2h. Okay. So once again, some easy ones there to simplify. Same with number 7, except for here we do have a negative we're distributing. So negative 3 times 6c gives me negative 18c. Plus, in this case, negative 3 times 1 is negative 3. So once again, we have this issue here where when we multiply by negative, we have this weird thing happen where it kind of changes our plus to a negative. So we have negative 18c minus 3. This one, once again, there's no number in front of the parentheses, but if there's not, we can technically add a 1. So that would be negative 1 we're distributing. So negative 1 times 4r is going to be negative 4r. And then, once again, taking a shortcut here, you can kind of think of this negative is going to change this minus 5s or negative 5s to a positive 5s. So actually, the answer here is negative 4r plus 5s. Okay. And then the last two here, same kind of deal. I'm going to write this as a sum because some people might still have a problem with seeing you need to distribute a negative 4 here. But if we write it as a sum, we can see that's what we're going to distribute. So distribute the negative 4. So we have 8 plus negative 8v plus negative 12, and then plus 7v. Well, we can add the negative 8v plus a 7v. That's going to give us negative 1v or negative v. and then we're going to have 8 and minus 12, which is, I'm going to take a little shortcut here because once again, if you've done this over and over again, you can kind of see we can go ahead and skip straight to 8 plus negative 12 will give us a negative 4, so minus 4. And the last one with these, same kind of deal here. Distributing a 5 and then a negative 1, since there's no number in front of those parentheses, just so we can clearly see that. I'm going to rewrite it as a sum. We do have A's and B's here, so this is the trickiest one probably we've ever had. Okay, but we're distributing a negative 1 here, so negative 9a plus, well, we're distributing a 5 here too, 5a plus 10b plus negative 1a plus negative 1 times negative 1, just 1b or 1b, okay? So in this case, what are our a's? Well, we got negative 9, 5, negative 1. So in this case, negative 9 plus 5, that would be negative 4 plus negative 1 gives me negative 5a. And then we have 10b plus 1b. That gives me a positive 11b. Okay, once again, double check yourself on those. Make sure you can do those, okay? Now, the only one that, if you do have trouble with number 10, I wouldn't fault you 100% for that because that one is tricky, okay? But if you can do number 10, then you should have no problem simplifying any expression that we throw at you, okay? But now, let's look at the other side of it, okay? Once again, let's zoom back out here. Keep clicking the wrong button there. And then let's zoom in so we can have some room here to write these out. All right, factor each expression. So once again, same exact thing we've just been doing the first part of that last of this section. So we just go through and factor our greatest common factor out. Greatest common factor here is 6. So when we factor that out, we're going to be left with n plus 4. So that's our factored version. Okay. 14y minus 14, greatest common factor there should be obvious at this point. That'd be 14. So when we take that out, we're going to have 1y minus 1. Okay. 3k minus 21, that one kind of looks a little familiar. I think we had something similar to that earlier. I think except there was a 6 here, but the greatest common factor here will be 3. So when we factor out or divide out a 3, we're going to be left with 1k minus 7. 27a plus 15. Okay. Once again, a little trickier here, getting bigger numbers, but I'll go ahead and tell you your greatest common factor here is, again, 3. So when you divide out a 3, you're going to get 9a plus 5. Okay. And then last two of the just factoring questions here, 8r minus 36. Greatest common factor here is actually, some people will be tempted to say 8, but it's actually just 4. So when we take out a 4 here, that's going to leave us with 2r minus 36 divided by 4 is 9. And the last one here, a 2-variable one, but we have p and q, okay? So in this case, and we got bigger numbers here, so this one's a little tricky, but I'll go ahead and tell you, okay, once again, go through all the factors. A lot of factors of 54. Well, not too many, but when you go through all the factors, you'll find the greatest common factor here is 6. And when you take out a 6, 12p becomes 2p plus 54q. This is the tricky part. 54 divided by 6 would be 9q. Okay. And that's all there is to factoring. But then the last type of question here, okay. So once again, let me zoom out and then zoom back into the bottom here. The exact last type of questions we've been doing in terms of simplify, then factor. So you're kind of combining the ideas of simplifying something, so getting rid of all the like terms, getting rid of all the parentheses. And then once you do all that, then bring back the parentheses. So undo the distributive property. Okay. So once again, we go through here and simplify. Okay. So to do it quickly here, we have 2w plus 5w. That's going to be 7w. And then we have -3, -9, and 40. So -3 plus -9 is -12 plus 40. That's going to give me a positive 28, so plus 28. Okay. And then once again, that's simplified. Okay. Now we do the same thing we just did up here. So we have something that looks like this. We're going to take out a 7 in this case, and that's going to leave us with a 1w plus 4. Once again, the two answers you should have there in terms of simplifying then factoring is the simplified version is 7w plus 28. The factored version is 7 times w plus 4 in parentheses. And then number 18, same kind of thing here. I'm going to quickly simplify this, meaning we're going to have x minus 7y. So this is going to be minus 7y plus 3x minus 11y. And then technically, if you want to, you can put a 1 in front of that x. So in this case, 1x plus 3x gives me 4x. Negative 7y plus negative 11y gives me negative 18y. So that's our simplified version. And now we factor. Okay, once again, factor. So in this case, our greatest common factor here is 2. So when we take out 2, that's going to leave me with 2x minus 18 divided by 2 is 9, and then we still have the y. So once again, simplify, then factor. If you do run into any problems with this, please let me know. I know this can be a little tricky, especially the last few examples there with simplifying, then factoring. But if you've got a good handle on simplifying and you saw how to factor, which once again, factoring, generally people have an easy time with that. But kind of combining the two, that can be a little tricky, okay? But as always, if you have any problems, let me know. Attempt the homework there. If you do run into any questions, like I said, always just email me, let me know, and we'll work through it. But other than that, I do thank you for watching.